In this video, we'll talk about this intuitive distinction between correlation and causality using some examples. Now, you might have heard about how correlation is different from causality, but this distinction is really key, a key concept in econometrics. Now, when you think about what economists are trying to do or what econometricians are trying to do, we are essentially trying to get to some sort of an accurate estimate of the relationship between two or more variables. A part of econometrics also deals with predictions. For example, if you want to know what would GDP growth be in the next quarter or what unemployment rates would be next week, we also do make predictions or we do forecasting, but that is not what econometrics is all about. Okay, most of the time, this is what we are interested in doing. So what we really want to do is we want to understand the data generating process that governs that relationship between two or more variables. So really we want to focus on what are the underlying laws that govern the data we observe, because remember we said that in econometrics most of the time we deal with observational data. So we look at that observational data and then try to make sense of it. Okay, so then try to establish that relationship. Which brings us to maybe our first example, which is to say, how do we make a distinction between correlation and causality? So let's take a simple example. Let's think about the correlation between wearing sunscreen and buying ice cream. Buying ice cream or buying lemonade. Okay, now you might think that overall or on average, people are more likely to wear sunscreen on the days that they are buying ice cream. Okay, so maybe this correlation on average is found to be positive. Okay, but then the question is for us, does buying ice cream cause people to wear sunscreen? You might think, well, perhaps no. There is something underlying about some other underlying factor about the relationship between wearing sunscreen and buying ice cream that makes this correlation positive. Okay, and that might be the weather conditions or the temperature of different days. Okay, so when we talk about causation or causality, when we are talking about causality, we are really interested in understanding or saying that X causes Y if changes in X change what Y is likely to be. Okay, so if this holds true, if we can change something about X, the variable X, and that leads to a change in what Y is likely to be, then we can say that X causes Y. Okay, now let's take another example to illustrate this point. So let's try to understand maybe the relationship between health and your overall health and going to the gym. So let's call this gym visits. Okay, so we don't know what we're going to find here, but maybe if we think about the correlation between overall health of individuals who are going to the gym, this might be negative. Maybe because this is maybe, okay? So maybe this is negative. So maybe people who are going to the gym are people who are unfit. Okay, so maybe they're unfit and that's why they're going to the gym. But can we then say, then the question is, does going to the gym or does going to the gym cause you to be unfit? Right? So this is this idea of causality, right? Can we say this? Can we infer this from just this correlation? The answer is no. What we really want to do is we want to, if we could somehow force people to go to the gym and then see the impact on their health, maybe we can ascertain something about that relationship. Okay, so even if the idea here is that even if there is a correlation that might exist between two variables, that doesn't mean that one variable is causing one another. Okay, a lot of times we use experiments. We use experiments, which is rare in economics, but they do exist, like we said. We could use experiments to help us study causality. Okay, so if we can go kind of reach in and change this treatment X, which is, let's say, gym visits for us, if we can tell and force people who are healthy or not healthy or fit or unfit to go to the gym and then ask what happens after certain gym visits, then maybe we have some idea about the health. Okay, or we could think about some sort of a counterfactual. We could say, what would have happened if the person did not go to the gym, right? So the counterfactual would be, what would have happened if a person did not go? So essentially, we want somebody who goes to the gym and look at their outcomes and then compare that to somebody who is a lot like this person who goes to the gym and then look at their health outcome, right? And maybe do a comparison between the two. And so the notion of keeping everything else fixed or ceteris paribus is very important to understanding causality. Okay, now here I just wanna make a point that, you know, experiments, while there are certain experiments that are carried out in economics, it's usually there are some problems with running experiments. Okay, so sometimes you can't really do an experiment because it is expensive, really expensive to carry out an experiment. There could be another problem that sometimes these experiments could be immoral or unethical. And sometimes these are just impossible to do, right? So I'll give you examples about this, but let's think about, you know, if we were trying to understand what is the value of another year of education on one's earnings, then we can't really assign different levels of education to different people and then try to assess what their earnings are going to be. That's just going to be immoral to do. Or we can't try to understand what is the effect of, let's say, the tax structure on corporate profits, because we can't change the tax structure and give different tax structure to one firm versus another, right? So in some cases, this is immoral. In some cases, this is impossible to do, and a lot of times these experiments can be expensive. So we'll see some examples shortly.